Question 15 is another kind of interesting question. We're looking for all points of intersection. And that we're really going to beg the question about what is it we mean by a point of intersection? Because if I'm going to look at this graphically, 1 plus cosine of theta, I know that this is a cardioid because the a and the b values are equal. I know this is going to be symmetric over the x-axis. I know that cosine of 0 is 1, so we're going to start out at 2, and then we're going to have 1. So 1 plus cosine theta looks exactly like that. 1 minus cosine theta, in fact, starts at 0. And when theta is pi, we're going to have cosine of pi is -1. So that would mean we're taking 2 steps out in that direction. So here's the graph of 1 minus cosine theta, this one. So I can certainly look at the points of intersection. It looks as though I have a point of intersection over here at, let's see, r is definitely 1, and our angle is pi over 2. And down here, r is definitely 1, and our angle is 3 pi over 2. And certainly we have another point of intersection when r is equal to 0, right? And I don't know what the angle is there. So I'm just going to write r is equal to 0. And in fact, theta could be anything. Well, let's see if we can do this algebraically. 1 plus cosine theta is equal to 1 minus cosine theta. The 1's can certainly cancel out, and that gives us 2. Cosine theta is equal to 0. So where is cosine theta is equal 0? Well, cosine theta is equal to 0 most definitely at theta is equal to pi over 2 and at 3 pi over 2. Okay, and all of that seems fine. Well, let's go back to our first equation. If I go back to r is equal to 1 plus cosine of pi over 2, that's going to give me 1 plus 0, so that gives me 1. Everything is as it should be, 1 pi over 2. Where it gets, and if I go to r is equal to 1 minus cosine pi over 2, I could try that also. That still is going to give me r is equal to 1. So this is a true point of intersection. Algebraically it works. We can see that on the graph. If we go to 3 pi over 2, I'm going to go to the first equation. 1 plus cosine of 3 pi over 2 is cosine of 3 pi over 2, though, is 0, right? So that still gives me r is equal to 0, and I can plug that into the other one, right? So that's r is equal to 1. Another point of intersection, 1, 3 pi over 2. The problem is, where is r equal to 0? Where is r equal to 0? If I was going to look at 1 plus cosine of theta equals 0, this is where cosine theta is equal to -1, which is at theta is equal to pi. And if I go back to the other situation, 1 minus cosine theta is equal to 0, that's going to give me cosine theta is 1, which happens at theta is equal to, well, 0 radians. So once again, this is a point of intersection. Let's just cut to the chase here. This is a point of intersection. And what I'm going to call it is a point of intersection, but it is not a collision point. If I was going to graph these two equations on my calculator, they would both go through the origin, but at different points. So I do, in fact, have 3 points of intersection. I might even say these are stronger points of intersection.